Hello everyone, welcome to Augmented Technology Private Limited. Today I am excited to introduce our one of the product, that is WIN-IO-4AOMV MV. It's a 4-channel analog output which is providing the output in the current also and the voltage also. So here we have the base model. In this model we have the power supply part here. So for this power supply we have provided the provision as the positive and the negative, where we can connect up to 24 volt DC in any direction. So here we use the bridge rectifier which supports the reverse connection for the board. And here we have the RS485 for the communication. So in this RS485 we have the configuration as the B for the negative, A for the positive. So we can connect with the RS485 cable with the PC to get the data. So here we have the dip switch part. In this dip switch, where user can set their own slave ID and the baud rates. For the baud rates we have already mentioned in the data sheet, and for the slave ID where user can set their own slave ID up to 15. And here we have the reset button. For this reset button, whenever user changing the slave ID and the baud rates, on that time just need to press the reset button once, so the board will get configured with the new slave IDs and the baud rate. So here we have the 2 AO part, and here we have the 2 AO part. Total 4 channel for the analog output. So in this AO part we have the jumper provision. So here we have the 10 bit and 12 bit also, and where you can set voltage and current also. Here we have the jumper part. So in jumper we have mentioned this is the voltage 10 bit 12 bit, and this is the current 10 bit 12 bit, and here you can set the voltage or current. Just by shifting the jumpers you can set the voltage, current, and also you can set the 10 bit 12 bit resolution. In this video we will only know about how to connect the power supply and how to connect the RS485 with the Modbus cable. Okay, here we have the power supply part. There we have mentioned in the board, that is positive and negative. Connect the power supply with the positive and the negative and provide the power supply. See here the LED turn on, that means power supply has provided properly. Then get to know how to connect the RS485 cable. Here we have provided the configuration as the B, that is for negative. Here I have connected the negative. A for the positive, I have connected the positive wire. So then connect this wire with the PC. Okay, this is the RS485 cable. So I am connecting this with the PC. Now we will connect the RS485 cable with the PC. So I have connected with the PC. Now open the device manager. In the device manager, go to the port here, that is showing as the COM6. That means I am using the port number 6 for the serial communication. So then go to the Modbus pole, click on connection, connect the board and select the port and click on OK. See, the board has connected properly. After proper connections, here you will get the RX and TX LED blinking continuously. That means RS485 communicating with the PC properly. In this video part, we will get to know how to configure the slave IDs and the baud rates. So here we have the slave ID and the baud rates. So by default that is the 9600 baud rate and the slave ID will be a 1. So now we will go with the PC. See here the board has connected properly with the default baud rate and the slave IDs. So now I need to change the slave ID as the 3. Okay, before changing the slave IDs, here this is the dip switch for the slave ID. So here in the dip switch they have mentioned 1, 2, 3, 4. That means the slave ID configuration as the 1, 2, 4, 8. That means if I need the slave ID 3, then I need to hide first and the second pin. That means 1 plus 2, that will be a 3 slave IDs. Okay, then I need the baud rate as a 19200. So the first pin that is mentioned in the board, that is 19200. So I will hide this pin. Now I need to press the reset. So the board will get for the new configuration. See, here I will get the timeout error. Whenever you will get the timeout error, disconnect the board and connect the board with the new configuration. The baud rate is 19200 and the slave ID will be a 3. Okay. See, after connecting this, here the TX has continuous increasing. That means the board has connected with the new slave ID and the baud rate. So now I need to set the slave ID as the 5 and the baud rate will be a 38400. So now I will hide the first pin slave ID and the third pin slave ID. That means 4 plus 1, that will be a 5. Now I will need to set the baud rate, that is 38400. That is the second pin. So I will hide this pin and now I will press the reset. See, here I will get the timeout error. Do the same thing, disconnect the board and connect the board with the new configuration. The baud rate will be a 38400. Okay, then the slave ID will be a 5. See, here the board has connected properly with the new configurations as a slave ID 5 and the baud rate 38400. So now I need to set the baud rate as the 57600 and the slave ID will be a 15. So if I need the slave ID as the 15, then I need to hide the all slave ID pins. That will be a 15. Okay. Now I need to set the baud rate, that is for the 57600. Okay. Now I need to press the reset button. Here I will get the timeout error. Then disconnect the board and connect the board with the new baud rate and the slave ID. Here the baud rate 57600 and the slave ID will be a 15. See, the board has connected properly with the new slave ID and the baud rate. Now I need to set the slave ID as the same and the new baud rate, that is 15200. See, okay, 15200, that is the new baud rate. Just press the reset, disconnect the board and connect the board with the new baud rate, that is 15200. Click OK. See, the board has connected properly because I have put the slave ID 15 as same and the only change, that is baud rate. Now I need to get back all these with the default. So load the all pins. Okay. Otherwise you can set only first pin as a high for the slave ID. Otherwise you can low. There is no issue. Now press the reset. The board has gone for the default slave ID and the baud rate. So now here I will get the timeout error. Disconnect the board and connect the board with the default address. Baud rate is a 9600 and the slave ID will be a 1. See, the board is communicating with the properly for the default addresses. Here the board has connected properly with the Modbus. So for this analog output we need one multimeter. So here I have the multimeter. So first two channel I have set the analog output as a voltage and the next two channel I have provided as the analog output as the current. So by default it's a 10 bit. For 12 bit also we can change and check the board with the 12 bit resolution also. So first for the 10 bit we have the 0 to 3 as a mentioned register. According to the datasheet you can check with the mentioned register data. So for the 12 bit after the 4 to 8, 4 to 7 there will be a 4 register for the 12 bit resolution. So now I am checking with the 10 bit. So first channel I will provide the 1023 as a full resolution for the 10 bit. So second channel I will provide the 512 full resolution as a half resolution. So third channel I will provide the 600 as a resolution and fourth channel I will provide as a 800 as a resolution. So for the first channel I have provided the 1023. In the first channel I will get as a voltage 12 volt 10 volt full voltage. So here I am getting the 9.9 volt. So I have provided the 24 volt DC power supply for the board. So I am getting the 9.9 volt for the first channel, and the second channel I am getting the 5.06. It's I have provided the 512 as the resolution, so I will get the 5 volt. So according to the resolution, you will get the voltage as 0 to 10 volt. So for the another two channel I have provided as the current. So for that we need to change the multimeter for the current. So in the third channel I have provided the 600 resolution, and in the 8th channel I will provide 1023 as a full resolution, so to get the difference. For the third and the fourth channel I made as the output as a current, so I have provided the resolution as a 600, and for the fourth channel I have provided the 1023 as a resolution full. So here I am getting the as a voltage as output as a current. So I have set the multimeter for the current. So now for the third channel I have provided the 600, so here I am getting the 13.3 milliampere, and for the fourth channel I have provided the 1023, so here I am getting the 19.8 milliampere. So if the fourth channel I will provide the 0, so I will get the 4 milliampere. So 4 to 20 milliampere it will show the output current, so according to the 10-bit resolution. So you can check with the 12-bit resolution. For the 12-bit resolution there is a mention register from the 4th to 7. So this all about indicates the board is working properly with the analog output for the current also, and for the voltage also, and with the 10-bit 12-bit resolution.